Welcome back, everyone. Let's please start with our further discussion. Next question is saying a company is designing a new ad serving application. The application runs on Amazon EC2 instances behind an application load balancer. The instances run in an EC2 auto scaling group. The company has the following requirement for its continuous integration and continuous delivery process. Developers must store and manage the code in a versioning repository. Developers must build the test and tested the code frequently. Developers must deploy the code to the production with an automated process, and updates should not cause any downtime for the application. So here it is specifically talking about DevOps tool sets. Let's see the option. The first option is saying use AWS code pipeline, store the application code in AWS code commit. That basically satisfies the first requirement. Build and test the application with code build that satisfies the second requirement. Deploy the application to a staging environment with AWS code deploy, and perform the traffic cutover by using a blue-green deployment type. Okay, all these options mentioned in A will be satisfying the requirements given to you. You can quickly read the other options too. Use the code pipeline, store the application deployment package in the S3 bucket with versioning enabled. Build and test the application with AWS Artifact. AWS Artifact is not used for building and testing the application. If you're aware about it, you can straightforward remove this answer. Store the application code as a package in the S3 bucket with versioning enabled. Deploy the application with Beanstalk. Perform the traffic cutover by using a blue-green deployment type. So from the question itself, you can see it's talking about creating a CI/CD pipeline. So C will also be eliminated. And finally, the D, which is store the application code as a package in the S3 bucket with versioning enabled. Test the application with AWS OpsWorks deployment hooks. Deploy the application with the OpsWorks stack update. So option A is basically meeting all the pointers. Let's select it and say confirm. It's correct. Okay. You can automate the whole code release process by using code pipeline. Code commit is a version control repository that can store and manage source code. You can use code build to test code and run build. Code deploys blue-green deployment type gives you the ability to verify a new deployment of a service before you send production traffic. Okay. A company is developing a microservice that will manage customer account data in Amazon Dynamo DB table. Insert, update, and delete requests will be rare. Read traffic will be heavy. The company must have the ability to access the customer data quickly by using a customer ID. The microservice can tolerate stale data. Which solution will meet these requirements with the fewest possible read capacity unit? Read the table by using eventually consistent read. Read the table by using strongly consistent read. Read the table by using transactional read. And read the table by using strongly consistent particular queries. It's saying that it can tolerate some stale data. Okay. So eventually consistent, choose it as an option. Okay. This would be the correct answer. You can see other options. B, C, and D. Okay. Let's move towards the next one. A development or a developer has an Amazon API gateway API that is integrated with an AWS Lambda function. The function reads and writes to a relational database. The developer analyzes the latency of the API and discovers that the initiations of the function connection to the database is adding significant time to the integration latency. How can the developer improve the latency without adding any additional infrastructure? Okay, what's the observation? The analysis says that latency of the API and discovers any initiation of the few functions connection to the database is adding significant time. Use provision concurrency for the Lambda function, initialize SDK client and database connection outside of the function handler. Increase the memory of the Lambda function, enable API gateway caching. Use DynamoDB accelerator, run the Lambda function in the same region as the database. Add a cache in front of the database. Clear the cache every 3 minutes. It is saying that when you're trying to establish the connection to the database, that is adding significant time to the integration latency. What you can do as a developer, you can use provision concurrency for the Lambda function. You can initialize SDK client and database connection outside of the function handler. Okay. You can see You can use provision concurrency to initiate the SDK client and database connection outside the function handler. This solution will prepare the connection to respond immediately to the function's invocation. The solution reduces time to the API gateway and reduces Lambda function integration latency. Okay. A developer is writing an AWS Lambda function that processes binary large objects of raw data and outputs batches of sanitized data. The Lambda function must store the sanitized data in the Amazon DynamoDB table. The developer tests the Lambda function and receives an access denied error during an attempt to write a batch of items to the DynamoDB table. It is something related to the permission. When permission is there, and if you want to establish the secure interaction between two services in AWS, you know role is a correct choice. So A option says Lambda's function execution role does not have appropriate DynamoDB write permission. If you will read other option, let's say B, it is talking about has exhausted its write capacity unit. So DynamoDB table has exhausted the WCUs. C is saying DynamoDB table is undergoing an auto-scaling event and cannot handle the request. And last option, which is option D, it is talking about connection to the DynamoDB is being throttled. Here, as it is related to permission, so choose option A, and that is correct. Number 25, a development team at an e-commerce company uses an SQS queue to store submitted orders. The team writes an application that runs on EC2 instances. The application reads orders from SQS queue and writes data to the relational databases. Cases of duplicate orders are discovered daily in the database. Which action will resolve the issue with the duplicate orders? When it is something related to duplicate order, you can think about first in, first out queue. That could be the one possibility. Or you can also think about visibility time. Okay, because when we talk about message visibility time, it is amount of time to which a particular message will be visible to a single consumer. Okay. And if that consumer has processed and deleted the message from that queue during that time, that message will not be visible to the other consumers. Okay. Let's read the option. In the first option, it's talking about maximum number of messages increase on the receive message API call beyond the current batch size of messages received in one call. So that's not matching the scenario. Second option is talking something about increasing the message visibility timeout on the receive message API call to beyond what's the longest transaction takes to process. Okay, let's choose B. We have to choose two options. Option number C is saying update the application so that it verifies that a message is not duplicate before writing to the data to the database. That would be correct. Set the wait time in the seconds to a non-zero value on the receive message API call. It's again not matching the scenario. Provide a unique message group ID for each message with the send message API call. Okay. Again, this is not matching the scenario. Okay. Let's see the correct choices by choosing B and C. It's correct. You can see if the visibility timeout expires before the message is processed and deleted, another consumer could retrieve the message and process it again. Chances of duplicate messages. Okay. Developers should design each application so that it does not create duplicates when processing the same message more than once. Now, if you would be thinking that why this is not correct, unique message group ID, read it. Setting a unique message group ID for each message helps the queue's throughput and latency at the expense of ordering. Changing the ID value would not affect the duplicate orders observed in the database. Okay, so B and C are the correct choices. A company is developing a new cloud printing platform. The platform design is fully serverless. The platform will use many different AWS Lambda functions to provide functionality. Many of the Lambda functions will need to use a common set of dependencies. The company wants the ability to centrally manage, update the dependencies as needed. The company does not want to update each Lambda function individually. Which action or which solution will meet these requirements with the least amount of code written? If you recall in the previous discussion also, I was talking about Lambda layer, where you can load the common dependencies that can be referred by multiple Lambda functions. And at a time, one Lambda function, you can have 5 layers attached. Okay. So in the first option itself, it's talking about something related to Lambda layer. Data zip file with the dependencies. It's a Lambda layer that references the zip file in the Lambda console. Add the layer to the configuration of each Lambda function that requires the dependency. You can read other options too. In option B, it is saying create a zip file with the dependencies, upload the zip file to the S3 bucket, load the dependency object from the S3 into each Lambda function. The question is says the company does not want to update each Lambda function individually. Okay. So I will eliminate B. In option C, it is saying create a Docker container image with the dependencies, publish the image to the ECR. Okay. Configure the Lambda function that require the dependencies as containers based on the image in ECR. Okay. Again, manual work would be there. And D, which is saying create a repository in the code commit, add a dependencies code to the code commit repository, use Git commands to access dependency code in each Lambda function. Again, we have to code it. Okay. We have to execute Git commands. So the most suitable option, which is looking to me, that is option A, and that is correct. Okay. Next one, the release process workflow of an application requires a manual approval before the code is deployed into the production environment. A developer needs to achieve this using AWS code pipeline. How should a developer meet these requirements with the least operational overhead? We want to add a manual approval before the code deployment. So you can simply use an approval action in a stage. Okay, I'm choosing this. You can read other options too. Option A, use multiple pipelines to allow approval. Disable the stage transition to allow manual approval. Disable a stage just prior to the deployment stage. Okay, so I will choose option B, which is correct one. You can always use an approval action in a stage. Valid code pipeline action types are source, build, test, deploy, approval, and invoke. An approval action is the most appropriate way to accomplish the requirement. Okay. A developer deploys an e-commerce application on Amazon EC2 instances behind ALB, application load balancer. The instances run in an EC2 auto scaling group. The instances are based on an AMI that uses an EBS root volume. After deployment, the developer notices that a third of the instance seems to be idle. These instances are not receiving requests from the load balancer. A developer verifies that all the instances are registered with the load balancer. The developer must implement a solution to allow EC2 instances to receive requests from the load balancer. So one thing, if you encounter any such scenario and if you are implementing it practically, check the target groups. Inside a target group, go to the target and check the reasons why EC2 instances are not receiving the request. One very common challenge is, let's say if I have registered my elastic load balancer in 2 availability zones and my EC2 instances have been provisioned in the availability zones other than those 2 availability zones, there could be a possibility that request will not be redirected to those EC2 instances. Okay, you will get a message that EC2 instance is not in an availability zone in which load balancer is configured. So by seeing all these options, I can see that B is looking correct to me, enable all availability zones for the ALB. I will choose option B, and that is correct. Okay, you can read about it. The most likely cause is an incorrectly configured ALB AGs because the instances are registered. You can enable and disable AGs at any time. After you enable the AG, the load balancer starts routing requests to the registered target in that AG. Okay. A website allows user to upload photos to Amazon S3. An S3 event invokes an AWS Lambda function that uses the Amazon recognition detect labels operation to detect real-world object with a photo. The website needs to store this data in a search index to allow users to quickly locate all photos associated with the label. Which solution will meet this requirement? Store username and label values as S3 object tags. Retrieve and index the object based on the tag by calling the describe tag API with a username and label value. Store username and label values as S3 object metadata keys. Include the XAMG meta prefix for each key. Search by metadata to find all the objects that share the username and label value. Insert an item for each S3 key level and use user combination into Amazon DynamoDB table. Create a global secondary index with a username as a partition key and label as a sort key. Call the query item API to the index to find all the objects that share the username and label value. And in the last one, insert an item for each S3 key, label, and user combination into DynamoDB global secondary index. Define the username as a partition key. Define the label as a sort key. Call the query item APIs from the index to find all the objects that share the username and same value. Okay. First of all, try to find a difference between C and D. In C, it is saying insert an item for the each S3 key label and user combination into DynamoDB table. Okay. Create a global secondary index with a username as partition key and the label as a sort key. And in the D, it is asking you to insert all these values in the DynamoDB global secondary index. Okay. If we will see other two options, it is saying store username and label values as S3 object tag, retrieve and index the object based on the tag by calling the describe tag API with a username and label value. And in the B, it is asking you to store the username and label values as the S3 object metadata keys. Let's try with option C. And let's check. So C is a correct answer. Let's see why A and B is not correct. A, many AWS resources supports the concept of tag. You can use tags. In order to manage, identify, organize, search for, and filter resources. However, the describe tag API reports only EC2 instance tag and does not support indexing. I'm looking for indexing. So main keyword is indexing. From that only you could go to the global secondary index. Okay. That is the option. Why D is not correct? DynamoDB automatically synchronize each secondary index with its base table. You can't insert item directly into an index. Okay. A company deployed an application as a set of microservices that run on ECS behind an ALB. The performance of the microservice has started to degrade for a specific set of user requests. The company needs to gain deeper insight in the request behavior that is associated with performance degradation. Again, the major point is performance bottleneck. When performance bottleneck is there, go ahead with the XLA. You can see other options too. In the option B, it is talking about perform distributed tracing based on ALB's built-in traffic request metrics. In C, it is talking about use CloudWatch to collect metrics and logs from ECS. In D, it is talking about creating an event-based rule. I'll go with A, which is saying create a Docker image that runs the AWS X-ray daemon, runs the image alongside the microservice in ECS, use the X-ray console to view the request to the microservices. And this is correct. Okay. So again, let's stop our discussion till here only. In my upcoming videos, I am going to talk about few more pointers with respect to more questions in this official practice set exam. Till that time, take care. And I will see you in the next video. Thank you, guys.